Next, we're going to look at two specific examples of parametric equations. So the first one is one that we've actually seen quite often before. And for the parameter, we're going to use the variable theta. So x of theta is equal to r cosine of theta, and y of theta is equal to r sine of theta. So these equations should look very familiar because they describe a circle of radius r. So we have basically a circle with radius r, right? Because recall that for a given angle theta, the x coordinate is going to equal r cosine of theta, so that's the x value, and then the y value is equal to r sine of theta. So as theta varies from 0 to 2 pi, it traces out this entire circle. So theta equals 0 would be here, theta is equal to pi over 2 would be up here, theta is equal to pi is down here, theta equals 3 pi over 2, and then finally theta is equal to 2 pi. The circle returns to its initial starting value. So as theta varies from 0 to 2 pi, these equations trace out the points on a circle of radius capital R. So that's our first example. Our second example is just how do you parameterize a line segment? So suppose we have something like this. So we have something like that. So we have an endpoint here and an endpoint there. So let's call these points x0, y0, and then up here we have the point x1, y1. So the question is, how do I parameterize a line segment between the points x0, y0, and the point x1, y1? So some sort of parametric equation that gives me the x and y values along this segment as a function of some parameter along the segment. So there is a way to do this, and the insight is that, well, line segments are linear, so why not try to use some sort of linear function? And then the other idea was, well, what if we do this between 0 and 1? So can I parameterize this so that when s is equal to 0, I'm at this point, and when s is equal to 1, I'm at that point? So the idea is, well, since it's a line, it would make sense that I'd be able to use linear functions to parameterize it. So let's see if we can do that. Well, what should x of s be when s is equal to 0? Well, x should just be x0. Simple enough. And then plus something times s. But when s is equal to 0, that gives me x0. And similarly, we have y0 plus something times s. So when the parameter s is equal to 0, the output will just be the point x0, y0. So that's done automatically by writing these equations like this. Now the trick for this point right here is to do x1 minus x0 plus x1 minus x0 s, and then plus y1 minus y0 times s. And what this does is the following. So when s is equal to 1, we get x0 plus x1 minus x0, so the output is just x1. Similarly, down here we get y0 plus y1 minus y0, and so the output is just y1. So when the parameter s is equal to 0, these equations return the point x0, y0, and then when the parameter s is equal to 1, these equations return x1, y1 automatically. And then it makes sense that if s is any fraction between 0 and 1, it's going to give you a point between those 2 points. For example, if s is equal to 1/2, you might get the midpoint. If s is equal to 3/4, you would get this point up here, and then so forth. So this is a handy way of parameterizing line segments.